we'll move on to the next topic. This is matrices. So let us try to define a matrix. Let us say we have m into n number of elements, like 2 into 3, like 6, and or 1 into 12, so 12 elements, like m into n. All right, let's say we have a set of mn numbers, m into n numbers, and we want to arrange those numbers in the form of a rectangular array. We can decide n rows, m columns, m row, n columns, or any particular type of ordering is possible, but the total number of elements will still remain same. If you try to arrange mn number of elements arranged in the form of a rectangular array having m rows, n columns, then we call that as a matrix. Okay, let's try to write that. A set of mn numbers arranged in the form of a rectangular array. So we are trying to represent in the form of a rectangular array of, let us say we have m number of rows and n number of columns. M rows and n columns, right, is called as a matrix. So this means we are going to call that matrix is of size or of order of matrix is, if we say this is m into n, this means m is the number of rows used to represent, and at the same time the n is the number of columns of that matrix. All right, now let's try to write a matrix A. This can be of size m into n. I should write m rows and n columns, right? So let me write the first element, first row, first column, first row, second column, first row, third column. Assuming that there are n number of columns, the last one will be a1n, because first row, nth column, second row, first column, second row, second column, second row, third column, and so on, second row, nth column. Like that we can write. Now we already have assumed there are m number of rows. So row number is a m, first column, mth row, second column, mth row, third column, and so on. Now you see the last element will be mth row. This is row number m, column number n. So there are m into n number of elements. Right? So the general way of representation of any element in a matrix, right? So elements of matrix. Okay, if I'm trying to write an element of matrix is denoted as Aij, where it's 1 less than I, less than or equal to I, less than or equal. You see, I represents the number of row here, so it is m. You can see here it's in all of the elements. The first element I is 1 to m. It can take any value 1 to m. Similarly, the j, sorry, I'll write the j with now. So this is 1 less than or equal to j less than or equal to n, because that's how when the j changes, we are changing the column of the matrix. So this is a representation. All right. So when it is close to 1, right, we are moving. If it is a column, we are moving from left to right as I change j value. At the same time, if you are looking at the I, right, then you are moving from top to down, top to bottom. Okay, all right. So that's how the Aij is used to represent the elements of matrix. Okay, now let's quickly go to the simple type of problem. This is just to give a practice to create a matrix, right? So the problem number 1 is construct a 2 cross 3 matrix. A is denoted by Aij, where, now this is part A of that question, Aij is equal to I plus 2j the whole square divided by 2. Right? I know that. What's the range of I? 1 less than or equal to I less than or equal to 2, because that's the m value for this problem. And also the j value is given. So 1 less than or equal to j less than or equal to 3. So I can take 1 and 2. J can take the values 1 and 3. So we have to create such matrix. So now this matrix A is equal to how many values we want? I need these values A11, A12, A13, because 3 columns. J is 1, 2, 3. But number of rows decided by I value only 2. So this is A21, A22, A23. This is what I need to create now. Now I have to substitute the various values possible for I and j to get the value. So we'll put 1 and 1 here, right? So that is A11 is equal to 1, sorry, I think the equation I'll just check once. Sorry, this is I plus 2j, not 1 plus 2j. This is I plus 2j whole square divided by 2. So this is, both are 1, 1 now. So 1 plus 2, the whole square divided by 2. 1 plus 2 is 3. 3 square is 9 by 2. Okay, so that means our first value is 9 by 2. So we'll move on to the second value, that is A12. So that is 1 plus 2 into 2, 4, the whole square divided by 2. So 4 plus 1, 5. 5 square is 25 by 2. So this is 25 by 2. Then we'll move on to move further. This is A13. So 1 plus 3 into 2, that is 6. The whole square divided by 2. So 6 plus 1, 7, square is 49 by 2. Let's move further. A21. A21 is equal to, this is 2 plus 2, the whole square divided by 2. So 2 plus 2 is 4, 4 square. 4 square is 16. 16 by 2 is 8. So the next entry will be 8. Okay, then A22 is equal to, this is 2 plus 2 into 2, 4, the whole square divided by 2. Okay, so 4 plus 2 is 6, 6 square, 36, 36 by 2 is 18. So the next entry will be 18. And the last one, this is A23 is equal to 2 plus 2 into 3, that is 6 square divided by 8 square, 64 by 2, so that is 32. So the last entry in this is 32, right? So this is the required matrix. So always we are supposed to create a 2 into 3 matrix according to this problem. Aij is given by some equation. Okay, let's move further. The next question here is the Aij is equal to half of the magnitude of 2i minus 3j. So if you get a negative number, make it positive. That's what is the meaning of the magnitude term. Okay, so we have to create the matrix satisfying this condition. Okay, so that means let's try to create the matrix now. So once again, we want to create the same A11, A12, A13, A21, A22, A23. So the matrix A is equal to A11, put this is 1 by 2 into, this is 2 into 1 minus 3 into 1. But I need to take the magnitude. So 2 minus 3 is minus 1. Magnitude makes it plus 1. So this is 1 by 2. All right. Similarly, calculate A12, that is half of I is equal to 1 and j is equal to 2. So 3 into 2 is 6. I have to take its magnitude. So 2 minus 6 is minus 4. It becomes plus 4 because of the magnitude divided by 2. So A12 becomes equal to 2. Okay, then calculate. Let's go for A13. This is equal to half magnitude of, this is 2 minus 3 into 3, that is 9. Its magnitude. So minus 7 by 2 becomes plus 7 by 2. That is A13. Then let's go for A21. So this is half the magnitude of 2 into 2. So that is 4 minus 3 into 1 is 3. So 4 minus 3 is plus 1. It doesn't change anything. So this is plus 1 by 2. Let's calculate the A22 here. So half the magnitude, 2 into 2, 4, minus 3 into 2, 6. So this is equal to minus 2 by 2, 4 minus 6 by 2. So we can see that this is 4 by 2. So that is 2. Okay. Then we have A23. So this is half, 2 into 2, 4, minus, this is 9. So magnitude makes it positive. So 5 by 2 is the required matrix. A22, just a second, 2, 2 into 2, 4, yes, sorry, my mistake, correct. So this is 1 now, very correct, this is 1. All right, so this is the answer. Let's move further. The next matrix to be created is like this. So let us say we want to use Aij. This is equal to I minus j if I is greater than or equal to j. All right, it's going to be I plus j if I is less than j. So this, I have to check every case and then only I can do this calculation. So let's try to write A now. So A is equal to if I and j are same or I is greater than j, I should perform I minus j, and that Ij is replaced by I minus j. For example, A11. You see I and j both are 1, 1. It falls under this condition and I should perform I minus j. That is 1 minus 1, so 0. A11 is 0. So this is true for whenever I is equal to j or I is greater than j. So, right? Okay, let's move ahead. A12, right? So 1, 2 means this is the condition. 1 is lesser than 2, so I should perform the addition, right? Second case, I plus j should be done. So this is 1 plus 2, so this is equal to 3. Then A13 is also same, 1 plus 3, it is equal to 4. Then let's come down. Next value, A21, you see 2 is greater than 1, so I should perform 2 minus 1, that is 1. then 2, 2, subtract 0, then A2, 3, 2 plus 3, so 5. Okay, this is the required answer, 0, 3, 4, 1, 0, 5. Okay, the next one. Right, calculate this one. Aij is equal to 2i plus 3j divided by 4i minus 3j the whole square. Okay, calculate this matrix. Okay, so the answer is 25, 60, okay, 60, 160, okay, okay, so 16, 121 by 25, okay, 49 by 25, 25 minus 169. Okay, that's right. So like this, we can create any matrix by using the relationship between I and j values. Okay, let's move further. Next, we are going to look at what is called as the types of matrices. Right. The first type is called as a row matrix. It's also called as a row vector. Right? So any matrix of size m into n with m equal to, oh, sorry, it's not n, it's m is equal to 1. Okay, any matrix with the number of rows equal to 1 is called as a row matrix. So always we try to write A is equal to a matrix A, IJ with 1 cross n. I is fixed to 1 only. J can take any values. For example, right, let me try to write a matrix A which is equal to say 1, 2, 3. Now we see this is 1 row, 3 column. I can write B is equal to 0.5, 1.5, 2.5, 8.9, 11.7, etc. Now you see this is 1 cross how much? 5. So this is 1 cross 5. So overall, if you have only one row, any number of columns, then that is called as a row matrix or a row vector. Very similar to this, we also have what is called as the column matrix, right? Or this is also called as the column vector. It's a column vector or column matrix. Now we can try to write this as A, which is once again represented in terms of Aij with n cross 1. Now you see that this implies n value is always fixed to 1. N cannot change, n is 1. The n can be any number. So if you try to write this, an example, so A is equal to say 1, 2, 3. Now we see 3 rows, but number of column is still 1. So this is right. So this is 3 rows. That's why the number of rows comes first. That is equal to 3. Number of column equal to 1. So similarly, write a B which is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So this is an example. So this is 5 cross 1. 5 rows, 1 column. Anything like this is called as a column matrix or a column vector. Then the next type of matrix is called as a rectangular matrix. So rectangular matrix is the one where M is not equal to N for any matrix A represented as Aij of M cross N. It cannot be 1 into 1, no 2 into 2, 3 into 3. This is not possible. It can be any other number. Okay. For example, 1, 2, 3, 4, 1, 1, 7, 2. Now we see 2 rows, 4 columns. Right? We can write another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, this is 4 rows, 3 columns. Again, M and N are not same. M and N cannot be equal, right? Anything like this, any matrix we write like this is called as a rectangular matrix. It looks like a rectangular shape for you, right? Then the next type is called as the square. It's a square matrix. Now let's consider the square case here. Now it should be M equal to N. Always the M and N must be same for any matrix denoted by Aij of size M cross N. M and N has to be same. So for example, let's write A. If I write 1, 2, 3, so I wrote 3 columns, I should write 3 rows now. 1, 2, 3, 1, 2, 3, 1, 2, 3. So you see this is of size 3 cross 3. Another one, 1, 2, 2, 1. So you see number of rows equal to 2, number of column is also 2. So this is a 2 into 2 matrix. All right, so that's a square matrix. Okay, in case of a square matrix, we have a specific name given to some of the elements. Okay, so all elements of a square matrix with I is equal to j, right, are called as the principal diagonal elements, right? In the sense, if you have a11, a22, a33, etc., you see it's I equal to j. For example, in the matrix A, what are the principal diagonal elements? Okay, in this case, we may not be able to distinguish because all numbers are same. I'll slightly modify 1, 2, 1, 3, 1, 1, 1, 3, 1, 1, 1, 2, etc. Now you see the 1, 2, 3 are the principal diagonal elements. 1, 2, 3, the principal diagonal elements. So similarly, on the matrix B also we can identify the principal diagonal elements as 1 and 1. Okay, yes. Now let us move further. The next one is called as the diagonal matrix. All right, let's check this matrix, right? Any square matrix, it has to be a square matrix at first. Okay, that's why any square matrix with Aij equal to 0 for I is not equal to j, right? Any aij, right, should be 0 if I is not equal to j. If I equal to j, I know that it is a diagonal element. So diagonal elements are not 0, but non-diagonal elements are 0. That's what is the meaning of this. So let's write an example. Example A is equal to, so 1 0 0 0 2 0 0 0 3. So you can see that this is a square matrix size 3 cross 3. So A11 is there, A12, A13 is not, right? A21, A23 are not there, A22 is there. Similarly, on the third row, A31, A32 are zeros, A33 is non-zero. So such matrix is called as a diagonal matrix. Right. Now there is a easier way to represent this. So normally this can be represented in the following format. So A is equal to, this is called as a diagonal matrix of, you can simply write the diagonal elements 1 comma 2 comma 3. Means whenever I say there are 3 elements, it must be a 3 row 3 column. Okay, and first diagonal element is 1, then 2, then 3. So I can also rewrite, say, another example. Say B is equal to, I can write this is diagonal of 1 comma 2. So this actually means the B matrix is 1 0 0 2. That's how we can write. All right, then let's go for the next matrix, which is called as a scalar. The scalar matrix, right, is first of all a square matrix. There are conditions. It has to be a square matrix and only diagonal elements must be present, but all the diagonal elements must be same. So a diagonal matrix. What is a diagonal matrix? We know now, because just now we defined diagonal matrix is a square matrix where only diagonal elements are non-zero, all other elements are 0. So now we are looking at a diagonal matrix with all the elements of diagonal are equal. So they have to be equal. That's the very fundamental condition, right? So let's try to define this. Okay, so Aij is equal to, this is going to be 0 if I is not equal to j, right? I not equal to j is 0. Now it's not just non-zero, it's a constant c, right? If I is equal to j, it's going to be a constant, some constant c. So what is this? C is a constant. Any matrix which satisfies this condition will be called as a scalar matrix. Right. So now let's write an example for this. So this is 5 0 0 0 5 0 0 0 5. So anything like this will be called as a scalar matrix. Now we see the C value is equal to 5. Okay. Let's move further. The next type of matrix is called as a unit matrix. Unit, or it's also called as an identity. Identity matrix denoted by capital I. Now let's try to define this now. So if I try to write a Aij, this has to be 0 when I is not equal to j, and this is 1 when I equal to j for any given matrix, right? For example, right, I can write, say, I2 is equal to second order 1 0 0 1. So if I want to write an example for I3, that should be 1 0 0 0 1 0 0 0 1. Okay, then we have another matrix that is called as a singleton matrix, right? This is any matrix. Okay, let me write. A matrix with only one element. So the matrix has, if a matrix has only one element, you will call that as a matrix with only one element is called as a singleton matrix. For example, if I write A is equal to just like 1, that's a singleton matrix. A is equal to, within the square brackets, I write say 5, 5.5, 10.5, whatever value. Single value is written means that's a singleton matrix. Okay, then we have upper or lower triangle matrix. Right? So upper or lower triangle matrix comes into picture whenever we have a square matrix in which either all the elements below the principal diagonal are 0 or all the elements above the principal diagonal are 0. Okay, so let me write a upper triangle now or lower triangle matrix. So a square matrix, it has to be a square matrix first, in which all the elements so for upper, I'll write first. Upper triangle means lower, below the principal diagonal are 0. Okay, all the elements below the principal diagonal is 0 is called as upper triangle matrix. And if all elements below the, okay, I already wrote the below, so that means it is a upper triangle. So now I have to write above. All the elements above the principal diagonal zero. This implies it is called as the lower triangle matrix. Okay, let's quickly write an example. So if I try to write a matrix A that is equal to 1, 2, minus 3, 4, this has to be 0, 0, 2, 3, 1, 0, 0, 1, minus 1, 0, 0, 0, 4. So you can see that every element below the principal diagonal 0. So if lower is 0, then the triangle is called as upper. Okay, so this is upper triangle matrix, UTM. Similarly, let's get an example for the matrix. This is P. So now diagonal elements above values are 0. So 1, 0, 0. This is 2, 3, 0. Then 5, 6, 7. Right? I can see that all the elements above the principal diagonal are 0. So because of that, we call this as the lower triangular matrix. So upper triangle and lower triangle matrices are this. Now, one very important point related to this, which had been asked many times in many competitive exams, right? So this is in note. The number of zeros in any triangular matrix, of order n is n into n minus 1 by 2. Just check. So go for a 4 into 4 matrix. So 4 into 4, this is the size of the matrix, 4 into 4. So n is equal to 4, m and n are same, right? So it says that n into n minus 1, 4 into 3, that is 12, 12 by 2, which is 6. There should be 6 zeros, right? So you can see that there are 6 zeros in this. Go to the order 3. So 3 into 2, that is 6 by 2, so 3. So there are 3 zeros if it is a 3 into 3. Now the question is, find the number of zeros in a upper triangular matrix of order 100. So what is the answer? If n is equal to 100, then find the number of zeros in the upper triangular matrix. Obviously, that should be 100 into 99 divided by 2. So that is 50 into 99. So that is equal to 4,050. So many zeros will be there. Okay, yes. Let's move further. There is another type of matrix. This is called as a horizontal matrix. So horizontal matrix is a matrix with Aij of m cross n such that horizontal means more columns. Okay, there are more columns than the rows. That means it looks like a horizontal value. So n is greater than m, or m is less than n. So let's take an example. This is 1, 2, 3, 4, 5, 6. So you see rows are 2, columns are 3. So it looks like a horizontally kept box for us. So that's why it's a horizontal matrix. Equivalent to this, we have also have the vertical. Vertical matrix is denoted by any Aij of size m cross n such that it is always m. The number of rows should be, that is m, is greater than n. N is lesser than m. So let's try to write a P now. So this is 1, 2, 3, 4, 5, 6. So number of rows 3, number of columns equal. Okay, then another important matrix. This is called as null matrix, right? Any matrix Aij is 0 irrespective of I and j. There is no relationship Ai, what is I, what is j, etc. Right? Any Aij, all the values should be 0. So if I write it 2 into 2, 0, 0, 0, 0. Right? You can also write 3 into 3. So b is equal to all 0, 0, 0, 0, 0, 0, 0, 0. So this is a 3 cross 3. Okay, that's a null matrix. Normally we deal with the null matrices of which are square in size. They are most commonly used in engineering applications and building mathematical models. Okay, so 2 cross 2, 3 cross 3 are common. Doesn't mean that you cannot write others. Definitely you can write size 1 into 2, 2 into 1, 3 into 5, 8 into 16. Doesn't matter, right? You can still write null matrices. Okay, next one is called as a submatrix. Right? So any matrix that is obtained by deleting certain rows or columns, certain rows or columns of a given matrix, right? So they are called as the submatrices. For example, if I write 1, 2, 3, 4, 5, and 6. Okay, 4, 5, and 6. If I try to write a matrix like this, so then I can try to write a submatrix of this by maybe it's not that you have to delete both rows and columns. Only one row you can delete or one column you can delete, right? So as a submatrix could be simply 2, 3, 5, 6. I just deleted the first column of the given matrix. So 2, 3, 5, 6 is a submatrix of the originally given matrix. So you delete either row or column or both, not just one row, one column. We can delete 2 rows, 2 columns, 2 rows, 5 columns, 3 rows, 2 columns, etc. Anything we want, we can do, right? So whatever remains is called as a submatrix. Okay, so these are the types of the matrix. Now we'll move on to the next topic, which is called as the trace. Trace of a given matrix. Right, so this is a value calculated as the sum of all the diagonal elements of a given square matrix is called as a trace of a matrix. Let's try to write a matrix A now. So A is equal to 2 minus 7 9 0 3 2 8 9 4. So if this is my matrix, now how to calculate the trace? So we'll denote it as TR of the matrix A. So let's write a capital A here. So TR of A is equal to simply the sum of the diagonal elements 2 plus 3 plus 4. So that is equal to 9. So we don't consider any other element that is present, right? And it has to be a square matrix. Only when we have the square matrix like this, yes, you can calculate the trace. So trace is also very important, and it has actually many features, and the features of a trace is used in, again, many applications. Okay, so which are the applications we are going to see in the next class.